जी जी ठीक है। अच्छा जी, today is 10th November 2025. It is Edexcel Physics IEL, and now today we are starting new chapter, that is solid material properties. And before starting this chapter, the past paper questions, obviously we should discuss its theory. And what is the theory? Let's start. The theory is, consider this is a spring, and this is the original shape and original size of the spring, and it is vertically hung. And if I apply a force with its free end, or if I hang a block with the other end, then obviously this force or the weight of the block produces deformation in the length of the spring. The spring is stretched by this force, and according to Hooke's law, extension in the spring is directly proportional with extension. If you apply greater force, there will be greater extension. So extension is directly proportional with applied force. Acha, if you release this force, and if the spring return back to its original shape and original size, then this property is called elasticity or elastic property. You applied a force on the spring. This applied force changes its length. It is called deformation. If you release the force and the object returns back to its original size and shape, then we call it, this spring is elastic spring. And for elastic spring, extension is directly proportional with applied force. And when you remove the sign of proportionality, then we use a constant, and this constant in IGCSE, we call this constant as a spring constant. But in A levels physics, we will stretch sometime wire, sometime we stretch a rod, so we cannot say only spring constant. So it's another name in Edexcel board physics. It is stiffness constant. It is called stiffness of spring, stiffness of material. So stiffness is calculated by K. And you know, stiffness is the opposite word of softness. So you know, some springs are soft, some springs are stiff. So it is calculated by this constant. And if you plot a graph between force and extension, then according to Hooke's law, the graph between force and extension is a straight line. And this straight line shows that if you are increasing force, extension is increasing at the same rate. But practically, if you are increasing force, consider zero force, zero extension. When force is 10 Newton, consider extension is 2 centimeter. When force is 20 Newton, extension is 4 centimeter. You are increasing force and extension is increasing at the same rate, but it is up to a certain value. And after this value, I am expecting, when applied force increase to 50 Newton, then the extension should be 10 centimeter. But practically, now the length increased at greater rate. If I apply force 60 Newton, I am expecting extension should be 12 centimeter, but consider the extension is 12.7 centimeter. It means up to this force, up to this force, the spring or the object is obeying Hooke's law. But beyond this force, now the spring is not obeying Hooke's law, and the graph of the spring will no longer remain straight line, but it begins to curve. It begins to curve. And this point up to which the spring or object obeying Hooke's law, it is called limit of proportionality. It is called limit of proportionality. So if I ask you what is the statement of Hooke's law, then you can write, sir, extension is directly proportional to the applied force within limit of proportionality. So limit of proportionality is the point up to which the object obeys Hooke's law, and beyond limit of proportionality, Hooke's law is not valid and it is a curve. But in A level physics, there is one more or one new term which a new term you should know, and the new term is elastic limit, and both are different to each other. Limit of proportionality is the point up to which the graph is a straight line, and this elastic limit is not limit of proportionality. Sir, what is elastic limit? So I am going to explain. If you are increasing force, then the graph is like this, and decrease force, if you decrease force, then the graph is same. If the graph of increasing load and graph of decreasing load is same, it means the spring has not crossed elastic limit. But consider this is the maximum force up to which increasing load graph and decreasing load graph is same. But as you apply further force, now you have crossed this point and now you start decreasing load, then the graph is not same. And if the graph of decreasing load is not same, then this point is called elastic limit. So you should note down its proper definition. The heading is, sir, what is elastic limit? Elastic limit means the maximum force up to which graph of increasing load and decreasing load is same. Graph of increasing load and graph of decreasing load is same. It is called elastic limit. And if you cross this force, then you can see the increasing load graph and decreasing load graph is not same. So elastic limit is the maximum force up to which increasing load graph and decreasing load graph coincide. Increasing load graph and decreasing load graph is same. Then this maximum force is called elastic limit. This maximum force is called इलास्टिक लिमिट. ठीक है, मैं अपनी बात रिपीट करने जा रहा हूँ और मेरी बात को अब्दुल्ला समझाएंगे. बेटा अब्दुल्ला गौर से सुनिएगा. अब्दुल्ला, मैं आपको दो बातें पूछने जा रहा हूँ. अब्दुल्ला भाई, आपका माइक्रोफोन चल रहा है? अब्दुल्ला, हाँ अब्दुल्ला बेटा ज़रा अलर्ट हो जाए और जो बात मैं पूछूं मुझे बताइएगा. लिमिट ऑफ प्रोपोर्शनलिटी, सर ये वो फोर्स होती है जहां तक ग्राफ स्ट्रेट लाइन होता है सर जहां तक स्प्रिंग हुक्स लॉ को फॉलो करता है। सर लिमिट ऑफ प्रोपोर्शनलिटी वो फोर्स होती है जहां तक स्प्रिंग हुक्स लॉ को ओबे करता है। अब्दुल्ला बताइए लिमिट ऑफ प्रोपोर्शनलिटी क्या चीज होती है? ठीक है जी, बेहतरीन हो गया, बेहतरीन हो गया। एंड नाउ सिमरा आई एम आस्किंग यू, द क्वेश्चन इज व्हाट इज इलास्टिक लिमिट? सर इलास्टिक लिमिट इज द मैक्सिमम फोर्स अप टू विच द ग्राफ ऑफ इंक्रीजिंग लोड and the graph of decreasing load is same. The graph of increasing load and the graph of decreasing load is same. This maximum force, it's called elastic limit. G. Simra, what is elastic limit? Okay. Elastic limit is the maximum force up to which the graph of increasing load and the graph of decreasing load is same. What is elastic limit? Yes, the graph of increasing load and the graph of decreasing load is same. Okay, so if you have crossed the elastic limit, for example, in this question, when you have decreased load to 50 Newton, I am expecting extension should be 10.2, but consider it is 10.1. It is 8.0. Sorry, it is 7.8. So readings are different. If you are decreasing load, if you are decreasing load, the graph is changed. It means you have crossed elastic limit. Okay. And now there is one more new term I am going to add. The new term is if you hang if you hang a load with a spring over a long time. ठीक है, आपने किसी स्प्रिंग पर एक लोड लटका के छोड़ दिया और भूल गए। ठीक है जनाब, आप लटका के चले गए और भूल गए। ठीक है जनाब, आपने आज इसको लटका के गए थे, सही जनाब, और जब आप 1 वीक लेटर आए, ठीक है जनाब, तो आपने फोर्स इंक्रीज नहीं की, यू डिड नॉट चेंज द अप्लाइड फोर्स, बट द लेंथ ऑफ द स्प्रिंग विदाउट इंक्रीजिंग लोड हैज फर्दर इंक्रीज्ड। ऐसा होता है। ठीक है जनाब, इफ यू फॉरगेट to unload a block from a spring and it is hanging for a long period of time, then without increasing load, the length of the spring increases itself। ठीक है जनाब, तो ऐसा कब होता है? तो मैं आपको बताना चाह रहा हूँ कि फॉर एग्जाम्पल this is the point and this point is called yield point. This point is called yield point. After this yield point, you are not further increasing force, but the length of the spring is increasing. Without increasing load. You are not increasing load, but you can see the length of the spring is increasing. And this point is called in Edexcel board physics, it is called yield point. ठीक, जैनब बेटा मैं रिपीट कर रहा हूँ, जैनब आप मुझे समझाएंगी। सर सम टाइम ऐसा होता है कि हम ब्लॉक को स्प्रिंग से बांधकर लटकाकर छोड़ देते हैं और भूल जाते हैं। ठीक, या कभी ऐसा भी होता है ना बेटा कि किसी चीज़ को हमने अपने घर की छत पे लटका के छोड़ दिया। ठीक है ना, छत पे कोई चीज़ लटकी हुई है, कोई कोई फैंसी आइटम लटका हुआ है। ठीक है जनाब, और आपने कुछ सालों के बाद आके देखा कि जिस चीज़ से आपने हैंग किया था वो इटसेल्फ थोड़ा सा बड़ा हो गया। ऐसा होता है, लटके लटके वो बड़ा हो जाता है। ठीक, तो जरा डेफिनेशन सुनिएगा। द एक्सटेंशन विदाउट increasing load, the point after which there is extra extension without increasing load, this point is called yield point. जैनब बता सकती हैं व्हाट इज yield point बेटा? बिल्कुल सही। ठीक। अच्छा, फॉर एग्जांपल एक वक्त ऐसा आया, जरा गौर से देखिएगा, आप स्प्रिंग लटका के छोड़ गए, भूल गए, और स्प्रिंग से वो लटका रहा लटका रहा लटका रहा, लटकते लटकते yield पॉइंट के आगे एक्सटेंड होते होते एक वक्त ऐसा आया कि खुद ब खुद ही वो टूट के गिर गया। जब वो टूट के गिर गया तो इट इज कॉल्ड ब्रेकिंग पॉइंट। ये तो खैर बिल्कुल ही कॉमन सेंस की बात है। इट इज कॉल्ड ब्रेकिंग पॉइंट। इट इज कॉल्ड ब्रेकिंग पॉइंट। ठीक है जनाब। यानी कि जो ऑब्जेक्ट है वो ब्रेक हो गया, तो आप समझ लें जहाँ ग्राफ एंड हो रहा होता है, the final point of the graph, it is called fracture point or it is called breaking point। ऑब्वियसली ये तो कॉमन सेंस की बात है कि सर जहाँ से ग्राफ गायब हो गया इसका मतलब है कि आगे कुछ है ही नहीं। तो जो लास्ट पॉइंट होता है इट इज कॉल्ड ब्रेकिंग पॉइंट। ठीक है। अरे चलिए, जब हम क्वेश्चन करेंगे तो इंशाल्लाह इस चीज़ को और फर्दर एक्सप्लेन करेंगे। तो अभी काम की बात बेटा ये बनी हमारे सामने समझ में आई कि राइट नाउ आई एम समराइजिंग। According to Hooke's law, sir, force and extension are directly proportional to each other. This K is called spring constant, but in A level physics, it is called stiffness of material. It is called stiffness of material. Number one. Number two, limit of proportionality is the maximum force up to which the graph is a straight line and the object is obeying Hooke's law. Elastic limit is the maximum force up to which increasing load graph and decreasing load graph remain same. Yield point. Sir, yield point is the point beyond which the object is extending without addition of force. You are not increasing force, but there is addition. This extension, which is without addition of force, then this point is called yield point. और जहाँ ग्राफ खत्म हो गया, it is called breaking point. Sometime it is called fracture point. ठीक है जी? So this is the theory. And now, if you are given a graph, force and extension graph, consider this is a force extension graph. This is force, this is extension. In your book, extension is denoted by delta S. So if you calculate the gradient of this line, the gradient of this line is called stiffness of spring. And if you calculate area under the curve, if we calculate area under the curve, it is called area under the curve. It is called, force into distance, force into extension. It is called work done. So when you are stretching a spring, it means you are doing work done on a spring. So area under the curve is work done on a spring. When you are stretching a spring, when you are stretching a spring, it means you are doing work on a spring. So usually work done is equals to half force into extension, half force into extension. So it is called, you can say it is work done on a spring, or it is called elastic potential energy. So up to the elastic limit, sorry, up to the limit of proportionality, work done and elastic potential energy having same meaning. Okay. And if you replace this force by this equation, then it is half K delta x into delta x. Then it becomes, half K delta x square. So these are two formulas, but I think in your Edexcel there is only one formula. So note down both formulas, but I am not forcing you to memorize the other formula because I don't remember कि ये Edexcel में है या नहीं। ठीक है, बट ये तो Edexcel में ज़रूर है। ठीक। Acha ji, now we should solve some questions on this topic, and then there is one more topic in this chapter that is called stress, strain, and young modulus. Okay, but we should practice on these questions, on these topics. Question number one. Question number one. So the question number one is from your book. Question number one. You have a spring stiffness constant 50. You know stiffness constant denoted by K. 30 centimeter long. Sir, it is delta x. How long would it be if 200-gram mass hung from it? Okay, you know mass is not a force, weight is a force. So W is equal to mg, it is equal to force. So first you should calculate force. So calculation is already here, तो मुझे दोबारा लिखना नहीं चाहिए. The mass of the block is mass is 200 gram. This 200 gram is converted into kilogram by dividing 1000. If you divide by 1000, then this 200 gram is equal to 0.2 kilogram. It is mass. And this mass is multiplied with gravity, that is G. So force is 1.962. बेटा कॉपी कीजिएगा. अब्दुल्ला बेटा लिखिएगा, लिखेंगे तो दिमाग में बैठेगा बेटा. अब्दुल्ला कॉपी कीजिए. We are given mass which is hung from it. So hanging mass is 200 gram, and this is converted into kilogram dividing by 1000, and W is equals to mg. It gives you force. So weight is 1.962 Newton, which will act as a force. Okay. And now I am using F equal to K delta X. So force is 1.962 divided by K. Sir, K is spring constant, and spring constant or stiffness constant is 50. So if you divide by K, then obviously you can calculate delta X, and this delta X is in meter 0.0392. This is in meters, and if you multiply with 100, then it is converted into centimeter. You know, book questions are very simple and past paper questions are very difficult. So by delta F upon K, you have calculated extension. This extension is in meter, and if you multiply with 100, it is converted into centimeter. It is converted into centimeter. And now what is the question? So the question is, what is the final length of the spring? How long would it be? You know, original length is 3 centimeter. Original length is 3 centimeter. This delta x is not extension. Sorry, this is the original length. This is the original length. Original length is 3 centimeter. We have calculated extension. Sir, extension is 3.9 centimeter. And if you add original length with extension, then it will be the final length. It is the total length. It is the total length. जी बेटा अब्दुल्ला बहुत सिंपल क्वेश्चन है. आपको समझ में बेटा आ गया है अब्दुल्ला? हाँ अच्छा जी, एक दफ़ा और समझा देते हैं हम आपको. अब्दुल्ला कह रहे हैं भाई एक दफ़ा और समझा दें, तो आई एम रिपीटिंग. सर, एक स्प्रिंग है. स्प्रिंग का कांस्टेंट डिनोटेड बाय के, एंड दिस स्प्रिंग इज 3 सेंटीमीटर लॉन्ग. ठीक है ना? तो कंसीडर आई एम ड्राइंग अ स्प्रिंग. दिस स्प्रिंग इज 3 सेंटीमीटर लॉन्ग. दिस स्प्रिंग इज 3 सेंटीमीटर लॉन्ग. इनको ना कॉल बैक करके बता दो कि सर बिजी है, बात कर लो, क्लास क्लास के बाद बात कर लूँगा. अच्छा बेटा, 3 सेंटीमीटर इज द ओरिजिनल लेंथ. ठीक है जी. अच्छा, व्हेन यू हैंग अ ब्लॉक एंड इट्स मास इज 200 ग्राम. ठीक है बेटा. तो यू नो 200 ग्राम इज मास, इट इज नॉट वेट. So beta, we should convert mass into weight because weight is force. So W is equals to mg, it will be weight. Weight is 1.962. 1.962. It is force or weight. So force is 1.962, K is given, so it is divided. So extension is 0.0392. But this is in meter. This is in meter. Sir, why is in meter? Because the spring constant is in meter, so the final length is also in meter. So if you multiply with 100, then it is converted into centimeter. So this is extension. Original length 3 centimeter. If you add extension, it will give you total length. So the final length is 6.9 सेंटीमीटर. ठीक है जी. अच्छा जी, आगे चलते हैं बेटा. नया क्वेश्चन. In this question, sir, we are given force along y-axis, extension along x-axis, and this is a line of best fit. This is line of best fit. We are given, okay? What is the question? The question is how much elastic strain energy is stored in the spring. You know, when a spring is stretched, then it stores elastic potential energy, or it is known as elastic strain energy, having same meaning. So elastic strain energy is stored in the spring, okay, up to a limit of proportionality. The question is when it is extended by 2.5 centimeter. So if you use this graph, then you can say that this is 2 centimeter, sorry, 2 centimeter extension. This is 3 centimeter extension. Okay. So 2.5 will be this point. This is the middle point. This is the midpoint of 2 and 3. So this is extension 2.5 centimeter. And when the extension is 2.5 centimeter, now check what is the force. Sir, force is 6 Newton. Force is 6 Newton. And sir, what is the formula to calculate elastic potential energy और इलास्टिक स्ट्रेन एनर्जी? तो अभी हमने आपको ऊपर पढ़ाया, फॉर्मूला होता है हाफ फोर्स इनटू एक्सटेंशन. हाफ force. Sir, we have noted force is 6 Newton and the extension is 2.5 centimeter. So this centimeter should be converted into meter. So I have divided by 100. I have divided by 100. So if you solve it, then the formula is half fx. This is the number which I have written already. So the final answer is 0.075 joule. 0.075 joule. So I am starting with very easy question from your book ताकि आपको थोड़ा फॉर्मूला समझ में आ जाए, एंड देन वी आर गोइंग टू स्टार्ट पास्ट पेपर क्वेश्चन. तो हमने एक क्वेश्चन कर लिया हुक्स लॉ का, एक क्वेश्चन कर लिया ग्राफ का, एंड नाउ वी आर गोइंग टू स्टार्ट अ न्यू टॉपिक. नाउ वी आर गोइंग टू स्टार्ट अ न्यू टॉपिक इन द सेम चैप्टर बट चेंजिंग द टॉपिक. दोनों का मैंने एक एक सवाल आपको करा दिया बेटा. अब मैं टॉपिक चेंज करने जा रहा हूँ. सर क्या टॉपिक चेंज होगा तो जरा सुनिए. नाउ आई एम एक्सप्लेनिंग यू 3 or 4 new definitions. Now the next heading is stress. Stress. Okay. Sir, we have studied already a term in the last chapter that is called pressure. Pressure is force per unit area. Pressure is force per unit area. In the same way, force per unit area, force per unit area to produce deformation. To produce deformation is called stress. You know, pressure has no connection with deformation. So we do not use the term pressure in this chapter. We use a new term force per unit area, and this is the force which is producing deformation. So force per unit area to produce deformation, it is called stress. It is called stress. So stress is a physical quantity just like pressure, but stress produces deformation. And the formula is written in the same way. Sir, stress is equal to force per unit area, and we have a symbol for stress, and the symbol of stress is this. This is just like 6, but it is not 6. It is not 6. It is like this, and we read it sigma. Okay, this is a symbol of sigma. A small letter, the capital letter sigma is this, and this is a small letter of sigma. So force per unit area to produce deformation is called stress, and when deformation is produced, then how do we measure how much deformation is produced? So to measure deformation, we use another term that is called strain. We have another term that is called strain. Sir, what is a strain? I am explaining you. Strain is defined as, consider this is a spring, and consider this spring length is 10 centimeter. The spring length is 10 centimeter. And when you applied a force, and this force produced deformation, so force per unit area is called stress. And now its length, this is its original length, and now its final length is considered 12 centimeter or 15 centimeter. If the final length is 15 centimeter, then obviously the extension is 5 centimeter. The extension is 5 centimeter. So if you divide extension by original length, if you divide extension by original length, then this ratio is called strain. So the definition of strain is delta x is extension, delta x is extension, and extension per unit original length, extension per unit original length is called strain, is called strain. And we have a symbol of strain as well. The symbol of strain is this. I think it is just like Ain in Arabic. Everyone knows Arabic, and in Arabic we write like this Ain, and this Ain in physics it is a symbol for strain. So strain is equals to extension per unit length, and it has no unit. It is not a physical quantity, it has no unit. Okay, so I am repeating and Abdullah will explain me. Abdullah beta, now we are adding two more definitions. Number one is stress. Sir, stress is force per unit area. And the second thing is strain. Sir, strain is extension divided by original length. हाँ बेटा अब्दुल्ला आई एम चेकिंग यू कि आप सो रहे हैं जाग रहे हैं. अब्दुल्ला जल्दी से बताओ स्ट्रेस क्या होता है, स्ट्रेन क्या होता है. व्हाट इज स्ट्रेस, व्हाट इज स्ट्रेन? अब्दुल्ला. ठीक है, एंड व्हाट इज स्ट्रेन? हाँ, per unit original length, per unit original length. Okay, so extension divided by original length, extension divided by original length, it is called strain. Okay, so stress produces deformation, and this deformation is measured by strain having no unit. Sometimes we express as strain in percentage, 20% is strain, 30% is strain. So if you multiply with 100, then it is in percentage. And now we are moving to the main formula. The main formula or the last formula of this chapter is Young modulus. It is the last formula. It is known as Young modulus. What is Young modulus? I am explaining. According to Young's law, stress directly proportional with strain. Obviously, if you exert greater stress, there will be greater strain. If you exert less stress, there will be less strain. Okay, so is- stress and strain directly proportional. And if you remove the proportionality sign and if you shift this strain on the other side, then the constant is called Young modulus. The constant is called Young modulus. And if I ask you define Young modulus, then obviously the definition is the ratio between stress and strain. The ratio between stress and strain is Young modulus. The ratio between stress and strain is called Young modulus. But a condition, the condition is within limit of proportionality. Within limit of proportionality. Sir, what is the meaning of limit of proportionality? The again, sir, if you plot a graph between force and extension, in the same way, if you plot graph between stress and strain, then the graph is a straight line, and this straight line up to this point is called limit of proportionality. This point is called limit of proportionality, and then obviously stress curve begin to curve, straight graph begin to curve. Obviously there will be elastic limit, there will be yield point, there will be breaking point, etc. So stress is same as force and strain is same as extension. So the graph is same and all the other concepts mostly are same. Not 100% same, but mostly are same. So remember, stress is force per unit area, stress is force per unit area, strain extension पर यूनिट लेंथ। और उसवा से अभी तक हमने पूरी क्लास में कोई क्वेश्चन नहीं पूछा। उसवा बेटा हम आपसे पूछना चाहेंगे आखिरी बात, जो पहले रिपीट कर लें फिर आपसे पूछेंगे। हाँ बेटा उसवा गौर से सुनिएगा कि स्ट्रेस एंड व्हाट इज द रिलेशन बिटवीन स्ट्रेस एंड स्ट्रेन। सर स्ट्रेस एंड स्ट्रेन आर डायरेक्टली प्रोपोर्शनल and their ratio is called Young modulus. Their ratio is called Young modulus. Uswa beta, what is Young modulus? बेहतरीन हो गया, बेहतरीन हो गया, ठीक है जी। अच्छा जी, थ्योरी खत्म, थ्योरी खत्म। And now we can solve a few easy question from your book. From your book. The question is, consider you have a cylindrical stone column has a diameter 60 centimeter and it supports a weight of 2500 न्यूटन। ठीक है जनाब, आपने देखा होगा आपके घरों में भी जब घर बनता है तो घर में जाहिर सी बात है कि पिलर्स होते हैं एंड ऑन दिस पिलर्स आपके घर की जो रूफ होती है वो उसके ऊपर सपोर्ट कर रही होती है। In this question, we have a cylindrical stone column, diameter 60 centimeter, and you are given weight. Weight is here, weight acting downward. It is considered the weight of the floor, 2500 Newton, and it is compressing this cylindrical stone. So it is called compressive stress. The stress which compresses an object, it is called compressive stress. And if you are stretching an object, then it is called tensile stress. Tensile means stretching. Tensile means stretching. And if you are compressing an object, then obviously it is called compressive stress. Okay. So the question is calculate compressive stress. Sir, stress is equals to force per unit area. Sir, force is the weight. Yes, force is the weight. Weight is 2500. In denominator area. You know area of circle because it is a cylinder. Cylinder means you know the shape of the cylinder is always considered like this. This is a cylinder. And in cylinder, the area for a section, the area for a section is pi r square. Pi is 3.1. What about radius? Sir, we are given diameter. Diameter is 60 centimeter. The half of diameter is called radius. Diameter 60, so the radius is 30. And this 30 is converted into meter, so it is 0.3 meter. And now this area will be 0.2826 meter square. So if you divide force by area, then it is called stress. And you can see the unit of stress and pressure is same formula, same unit. The unit of pressure is Pascal and the unit of stress is also Pascal. So this question is completed. And now the next heading is strain, which we have already discussed its theory. The theory of the strain is extension divided by original length. And this is the symbol, and usually it has no unit, but we can express strain in percentage. And now this is a question. It is the last question. Then we will start original questions from past papers. Okay. So it is the last question. So we should complete it. The question is a copper wire of length is 1.76 meter. Sir, it is the original length. It is the original length. And this copper wire is stretched by a force, and now its length increases to 1.80 meter. So 1.80 final length, sir, 1.76 the original length. So the extension is 0.04 0.04 meter. It is the extension. And if you divide this extension by original length and multiply with 100, then strain is 2.3%. So the strain is 2.3%. Okay. So I think this question is completed. And tomorrow at the same time, we will continue this sheet. And I hope today's theory, which we have studied, theory is very simple. But tomorrow we will start past paper questions from June 2019 and October 2019. And you can see past paper questions are not so simple. मनाइल देखने ग्राफ कितने अजीब व गरीब से नजर आ रहे हैं, ठीक है? तो इंशाल्लाह tomorrow we will discuss these graph as well. Right now I am ending my class.